Welcome to Basic Math. This is lesson 1 of 30 lessons that are designed to give you a foundation in mathematics to prepare you for mathematics in school as well as in life. My name is Murray Siegel, and I will be your guide through these 30 lessons to discover all kinds of interesting and even fun aspects of mathematics. But besides teaching you how to do mathematics, this tape series has another much more important objective, and that is to give you a feeling of confidence that you can do mathematics. In my years of teaching, I've run into many people, students, parents, adults, even senior citizens, who are afraid of mathematics, and some people are even proud of that fear. I get parents all the time who tell me, I can't do mathematics. They're very proud of that, as if I don't think they would say that they're proud they couldn't read. And to me, 85% of being able to do mathematics is having the confidence that you can do it. So one of the purposes of this series of lessons is to give you that confidence. Now, in order to get that kind of confidence, one of the things you have to do is follow along in the tapes and do the work. There's a couple of particular aspects of this tape series I want to explain now, and hopefully you'll follow those instructions. The first is we will have two different types of visuals on the screen. The first one is there now, and it's warning you to stop the tape and to think. I'll ask a thinking question, and I really want you to stop and think about it for a while, because when we discuss it, if you haven't thought about it, then it won't be as meaningful, I think, as if you stopped and thought about it, maybe taking 10 minutes and jot down some ideas. The second screen visual will tell you to stop and work a problem. And this is where I will give you a problem on the screen, and you'll stop the tape, work the problem to the best you can, and then come on back because, of course, I will show you the solution. If you don't stop the tape, then that's called cheating. Another thing you need to do is understand that if some of this material is new to you, and after watching my explanation you still do not get it to the extent that you'd like to, the wonderful thing about videotape is you can rewind and watch it again. And sometimes the second or even the third time through, something will click. In mathematics, that happens a great deal. You don't understand something, but by hearing a second or third time, working the problem, whatever it is, all of a sudden it comes together. And that's very important, because as I said, 85% of success in this subject is due to confidence, the confidence that you can do it. And of course, we here believe you can do it, but until you believe it, it does us no good. Another thing is to use our workbook. The workbook has a series of problems designed to supplement each lesson. And I would certainly work all those problems, and the answers, of course, are included in the workbook, so you can check and make sure you're right. For those of you who are taking this course as an initial situation, in other words, a young person who is learning for the first time about whole numbers and fractions and decimals, etc., I would suggest also getting us some sort of textbook. Again, additional exercises to reinforce that you are understanding how to do some things. But understanding how to do something is only part of the course. One of the things I'm concerned about is that I want you to understand why it works. One of the things that I'm concerned about when I teach is that my students understand why each new method, each concept works. A lot of times in mathematics we tend to learn how to do something. We memorize what's called the algorithm, the method, and we learn it and then we forget it, and we have to learn it again and we forget it again. If you understand why it works, then perhaps that method will stay with you longer. Plus it'll make more sense. Another thing, and I'll try to do this whenever possible, is to show you how that kind of mathematics is used in what's called the real world. Because a lot of times we learn math, and if you ask the teacher, when will I ever use this? Well, you'll need it to pass the test. You'll need it for the next course. You'll need it to go to college. And to me, that's not enough. We need mathematics to provide understanding of what's going on in the world and how to solve real problems. Another thing that I want you to understand about mathematics is that mathematics is consistent. That is, things we learn about whole numbers are true for fractions and for decimals, and even we talk about algebraic polynomials, for example, in the Algebra 1 tape, we are consistent. And a lot of times, some textbooks and many teachers don't make that a very important part of their teaching. And I think it is a very important part for you to understand the consistency. So when you come to a new subject, for example, fractions or algebraic polynomials, it's not something brand new. You can relate it to things you've understood in the past. Now, for an example of some things in terms of consistency, whenever we talk about adding, we talk about counting, because adding is always counting. Whenever we talk about subtraction, and again, subtracting fractions, subtracting decimals, subtracting anything, we're always doing the opposite of addition. When we multiply, our multiplication, as we'll talk about further in Lesson 2, multiplication is repeated addition. I don't care what you're multiplying, you're always doing a repeated addition process. And anytime we're dividing, we are doing the opposite of multiplication. These consistencies are very important, and you'll see them as we go through the various types of mathematical exercises. The first question I generally ask a class, whether it's a group of first graders or high school students or adults who are going back and trying to relearn mathematics or overcome their fears or get an equivalency diploma or be prepared for a college-level mathematics, is what is the most important word in mathematics? And this is one question that most people immediately know the answer to, and that is number. Mathematics is about numbers. My next question, the answers are generally not quite as secure, and that is, what is a number? People will say, well, a number is like 2 or 3, or a number is, and they get really hung up because a number, you see, is an amount. It's a quantity. It tells us how much or how many. And as long as we understand that, then when we work with numbers, we have a basis to understand how we do what we do with those numbers. You may say, well, I knew that. Yeah, but the fact is, I'm concerned with your ability to state the answers. In other words, if I say to you, I met you on a street someplace, and I said to you, what's a number? I'd expect you to be able to say, without even thinking about it, well, a number, of course, is a quantity. It answers the question, how much or how many. So no matter how you're using a number, it is always, that's what it is. The number is a quantity. And we use numbers for counting. And in fact, originally, that's how numbers started. I mean, ancient ancestors had to count things. How many people lived in a cave? How many animals they killed in the hunt? How many suns had it been since the last outdoor picnic, whatever it was. And then eventually, they used their fingers to represent these counts so they could communicate to themselves and communicate to others what they were talking about. Eventually, the numbers got bigger than the amount of fingers they had, and they used symbols, perhaps scratches on a rock or scratches on a cave wall. And eventually, these symbols became sounds, grunts, until we come up with our modern-day numbers like 7 and 12 and 2,512. Our number system is based on 10 digits. Did you ever think about why? Probably not, because most people that's our number system. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all our numbers use only those 10 digits. Well, the reason is because our ancestors, as well as ourselves, had 10 fingers. In fact, one of the synonyms for finger is digit. What if our ancestors had been Mickey and Minnie Mouse? Now, Mickey and Minnie Mouse only have 8 fingers, 3 fingers and a thumb. Then we would not have 10 digits. We'd have 0, 1, 2, 3, 4, 5, 6, 7. And that'd be it. And if you think about that, a lot of people get confused by that. But the fact is, from the time we're old enough to understand, as a young baby, we start counting and we understand 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the idea is to deeply understand what we're dealing with. To overcome a lack of understanding of mathematics, we need to understand that numbers are nothing more than symbols we've devised to express an amount. Okay? Now, one of the key factors in understanding how to work with numbers is something called place value. And as we talk about whole numbers and fractions and decimals, we will get into place value. But to say right now, place value is telling us what we're counting. For example, if I am counting cows, mathematics, okay? But let's talk about addition. Now, generally, when I ask students, and again, those students could be first graders, fourth graders, high school students, college students, even mathematics teachers, adults, whatever, whoever I've asked, what is adding? I generally get the same answer. Adding is putting two numbers together. And in many cases, that's true. But is it always true? Well, our first visual shows you a simple problem. The problem is 1 plus 3. And if I said, what's 1 plus 3? Everybody here would say 1 plus 3 equals 4. Ah. But if you told me that adding is putting two numbers together, then as our next visual shows you, 1 plus 3 is the letter B. Because I've literally combined the 1 and the 3 to form the letter B. You say, no, that's not what I meant. And that's what I'm getting at. Being able to successfully define or explain mathematical terminology is exceptionally important. And mathematics is very precise, very definite. Addition is not always putting two numbers together. Addition is always counting. And when we count, we can only count things that are the same. That's very important. So, for example, if I had a class of boys and girls, and I had 10 boys and 11 girls in the class, and someone said, well, add those up. 10 plus 11 is 21, but 21 what? 21 boys and girls? That's not specific enough. 21 boys? No. 21 girls? No. 21 students, 21 children, 21 people. I've redefined boys and girls to be students or children or people so that indeed I can add them. That is, I can only count things that are the same. You may say, well, that's silly. No, it's not, because understanding that notion that adding is counting and we can only count things that are the same will help us understand the adding of fractions and decimals and other things as we go on, and even help us beyond this course in more advanced algebra topics, even in calculus. So, again, this is a foundation course, and therefore I believe it's very important for every student out there to understand exactly what adding is. And subtracting and multiplication and division, the same idea. Okay, so let's take a look at the next visual. It shows an addition problem. And as soon as you see it, you say, well, something is wrong. 34 plus 5 is 84? That's silly. 3 plus 5 is 8. 4 is 4. 84. No, that's not right. You got to put the 5 under the 4. Well, I don't want you to tell me what I have to do. I want to tell me why that's wrong. Why 34 plus 5 is not 84. And the answer, you see, is very important. The answer is that the 3 is 3 tens. The 5 is 5 ones. And I cannot add tens and ones. Why not? Because adding is counting. I can only count things that are the same. So if I was trying to add 3 tens and but basically imagine I went into my wallet, if I had money in my wallet, and I had 3 $10 bills and 5 $1 bills. And I said, what do I have? Well, I would have $35, but how many pieces of paper, how many U.S. currency bills do I have? I have 8. The 3 tens and the 5 ones are 8 bills. So what I've done there is I've used a common place value, a common descriptor, changing it from tens and ones to bills. So 3 plus 5 is 8, and since both the 3 and the 5 were bills, I have 8 bills. So it's really important to understand the concept that adding is counting, and when I'm counting, I can only count things that are the same. Now, let's talk some specifics about what you should know about addition. Obviously, we line up the place values. We remember that if we're adding and our answer, let's say the answer is exceptionally important. And again, we'll talk more about this as we go along, and especially we talk about calculators in Lesson 11. Okay. Well, we've talked about what addition is. The next question, of course, is what is subtraction? What is subtraction? Well, if you listened earlier in the tape, I said that subtraction is the opposite of addition. Some people would say it's counting backwards, okay? Because adding and subtracting are both counting. That's important. The rules for addition and the rules for subtraction are very much the same because they're be. Now, at this point in time, I am 54 years old. Let's say my wife was 30. And I said, how much older am I than my wife? Well, 54 minus 30. Am I taking away 30 years and becoming a 24-year-old again? I wouldn't mind that, I guess. But the fact is, no, I'm not. I'm not taking away. What I'm doing there is I'm comparing. I'm looking for a difference. So sometimes subtraction is a difference. Other times, we're really looking to what we must add to a number to get another number. In other words, well, let's take a look at 12 minus 7. And 12 minus 7, what does that mean? Well, to me what it means is what must I add to 7 to get 12? Okay? Now, we've all memorized our subtraction facts, and certainly you know that 12 minus 7 is 5, but the reason you know that is because you know that 7 plus 5 is 12. Now, let's take a look at 8 minus 5, a very simple subtraction problem. We all know the answer, but we're going to use this to show you the different methods of subtraction and a visual explanation that will help us later on when we talk about subtracting integers, that is, numbers with positive and negative signs. The first visual shows you two bars, I guess you can call it, almost like a graph. One is marked 8 and one is marked 5. The number on the right is always the second number. That's always the number we're subtracting. So this is a problem representing 8 minus 5. Okay. The second visual shows you the taking away idea. We have 8 and we're going to take away until we get down to 5. And of course, it shows that we'll actually take away 3. 8 take away 5 leaves 3, or 8 take away 3 leaves 5. There's two possibilities there. The next visual shows you how we, in effect, add to the second number to get 4. So what do? Well, some students, unfortunately, reverse it. Say, well, I'll just do 6 minus 4. That's wrong. What I've got to do is I've got to borrow. This is 4 tens. That's 1 100. So I borrow the 1 100 and change it to 10 tens. So I had 4 tens. I now have 10 more tens. I have a total of 14 tens. And 14 minus 6 is 8. And the answer is 84. And by the way, in terms of estimation, if I had said that's approximately 150 minus 60, I'd expect an answer around 90. And certainly 84 is a ballpark figure. And it'll be very, very important to get used to doing that estimating to ensure that your answer makes a good deal of sense. Okay. Let's try another one. I'm going to erase this. And this time we're going to do 315 minus 196. Okay, let's go ahead and do our estimate first. Let's see. 300 minus 200. That's 100. I'm always going for nice round numbers. Numbers in the teens, the tens, in other words, 30, 50, 70, or numbers in the hundreds like 300, 400. So 300 minus 200 is 100. So my answer should be close to 100. Let's find out. Can I subtract 5 minus 6? No, I can't. 5 is less than 6. So what must I do? I must borrow. And I borrow 1 from the tens place, which gives me 0 left in the tens place. And I change that 1 10 into 10 ones, which now gives me 15 ones. Again, subtraction only in the place values. 15 minus 6 is 9 ones. Now I look at the tens place. And by the way, let me say something at this point. When you look, hopefully that all makes sense, and we'll see you in Lesson 2, Multiplication and the Introduction to Division.